Article 310.2 is the appropriate code section to cite. Article 310, Conductors for General Wiring, covers the requirements for conductors used in general wiring, including feeder circuits. Article 310.2 grounding conductor states that an insulated grounding conductor shall be provided for each branch circuit and branch circuit extension unless the branch circuit is protected by a ground fault circuit interrupter. In the case of a 3-wire feeder circuit, the bare grounded conductor serves as the grounding conductor. Therefore, according to Article 310.2a, it is required to be insulated. However, it is important to note that there is an exception to this rule in Article 250. Article 250.118 allows bare grounding conductors for feeders to be used as specified in Articles 210, 215, 220, and 225. Therefore, as long as the 3-wire feeder circuit in the detached garage was installed in accordance with one of the articles listed in 250.118, it would be acceptable to use a bare grounded conductor even though it is not insulated. Let's delve into the specifics of these National Electrical Code articles to understand the requirements and exceptions related to grounding conductors and feeder circuits, particularly in detached garages. We'll start with Article 310, which generally addresses conductors for general wiring. This article provides comprehensive guidelines for selecting and installing conductors, ensuring they are suitable for their intended application. It covers various aspects such as conductor types, ampacity, insulation, and installation methods. Article 310.2a, specifically focusing on grounding conductors, emphasizes the importance of using insulated grounding conductors for branch circuits and branch circuit extensions. This requirement is intended to enhance safety and minimize the risk of electrical faults. The rationale behind this insulation requirement is to prevent unintentional contact with grounded surfaces or other conductive materials, which could lead to ground faults and potential hazard. The exception to this rule is when the branch circuit is protected by a ground fault circuit interrupter. A ground fault circuit interrupter is a safety device designed to detect ground faults and quickly interrupt the circuit, preventing an electrical shock. In situations where a ground fault circuit interrupter is installed, the need for an insulated grounding conductor is reduced, as the ground fault circuit interrupter provides an additional layer of protection. However, it's essential to understand that this exception only applies to branch circuits protected by ground fault circuit interrupters. In the context of a 3-wire feeder circuit, the bare grounded conductor typically serves as the grounding conductor. This means that the bare conductor is connected to the grounding electrode system, providing a path for fault current to return to the source. According to Article 310.2a, this bare grounded conductor is generally required to be insulated. This requirement aims to ensure that the grounding conductor is properly protected and does not come into contact with other conductive materials, which could compromise its effectiveness. However, as previously mentioned, there is an exception to this rule in Article 250. Article 250, specifically focusing on grounding and bonding, provides comprehensive requirements for grounding electrical systems. It covers various aspects such as grounding electrode systems, equipment grounding conductors, and bonding methods. Article 250.118 specifically lists permissible types of equipment grounding conductors. This section outlines the types of conductors that are allowed to be used as equipment grounding conductors, providing clarity and guidance for electrical installers. Article 250.118 permits the use of bare grounding conductors for feeders subject to certain conditions. This exception allows bare grounding conductors to be used in feeder circuits as long as they are installed in accordance with Articles 210, 215, 220, and 225. This means that the feeder circuit must comply with the requirements outlined in these articles to be eligible for the exception. Let's take a closer look at the specific articles mentioned in Article 250.118 to understand their relevance to the exception. Article 210 covers branch circuits, providing requirements for their installation and protection. This article addresses various aspects such as conductor sizing, overcurrent protection, and receptacle placement. Article 215 focuses on feeders, providing requirements for their installation and protection. This article covers topics such as feeder sizing, overcurrent protection, and voltage drop calculations. Article 220 deals with branch circuit, feeder, and service calculations, providing methods for determining the appropriate size of conductors and overcurrent protection. This article outlines the procedures for calculating the load on electrical systems, ensuring that they are adequately sized to handle the anticipated demand. Article 225 covers outside branch circuits and feeders, providing requirements for their installation and protection. This article addresses topics such as overhead conductor clearances, underground conductor burial depths, and protection against physical damage. In the specific case of a 3-wire feeder circuit in a detached garage, the exception in Article 250.118 allows the use of a bare-grounded conductor if the circuit is installed in accordance with one of the articles listed, like Articles 210, 215, 220 or 225. This means that the feeder circuit must comply with the requirements outlined in these articles to be eligible for the exception. For example, the feeder circuit must be properly sized to carry the anticipated load, and it must be protected by appropriate overcurrent devices. Additionally, the feeder circuit must be installed in accordance with the relevant requirements for outside branch circuits and feeders, ensuring that it is adequately protected from physical damage and environmental factors. It's important to note that the exception in Article 250.118 is not a blanket authorization to use bare-grounding conductors in all feeder circuits. The exception only applies if the feeder circuit meets the specific conditions outlined in the referenced articles. If the feeder circuit does not comply with these requirements, then an insulated grounding conductor is required. Therefore, when inspecting a 3-wire feeder circuit in a detached garage, it is essential to verify that the circuit is installed in accordance with the relevant articles such as Articles 210, 215, 220 or 225 to determine whether the use of a bare-grounded conductor is permissible. If the circuit complies with these requirements, then the use of a bare-grounded conductor is acceptable. However, if the circuit does not comply with these requirements, then an insulated grounding conductor is required. Let's consider some practical examples to illustrate the application of these code requirements. Example 1. A 3-wire feeder circuit is installed in a detached garage to supply power to lighting and receptacles. The feeder circuit is sized according to Article 220, ensuring that it is adequate to handle the anticipated load. The feeder circuit is protected by an appropriately sized circuit breaker, providing overcurrent protection. The feeder conductors are installed in conduit, providing physical protection. In this scenario, the feeder circuit complies with the requirements of Article 215 and 225. Therefore, according to Article 250.118, the use of a bare-grounded conductor is permissible. Example 2. A 3-wire feeder circuit is installed in a detached garage to supply power to a subpanel. The feeder circuit is undersized, meaning that it is not capable of carrying the anticipated load. The feeder circuit is protected by an oversized circuit breaker, which does not provide adequate overcurrent protection. Feeder conductors are not installed in conduit, leaving them vulnerable to physical damage. In this scenario, the feeder circuit does not comply with the requirements of Article 215 and 225. Therefore, according to Article 250.118, the use of a bare-grounded conductor is not permissible. An insulated grounding conductor is required. In conclusion, when inspecting a 3-wire feeder circuit in a detached garage, it is crucial to understand the requirements and exceptions related to grounding conductors. Article 310.2 generally requires the use of insulated grounding conductors. However, Article 250.118 provides an exception, allowing the use of bare-grounding conductors if the feeder circuit complies with the requirements of Articles 210, 215, 220 or 225. By carefully evaluating the installation and ensuring compliance with these code requirements, electrical inspectors can help to ensure the safety and reliability of electrical systems in detached garages. It's also important to consider any local amendments or interpretations of the National Electrical Code that may be in effect in the jurisdiction where the inspection is being conducted. Local amendments can modify or supplement the requirements of the NEC, and it's essential to be aware of these changes to ensure compliance. Furthermore, it's always a good practice to consult with a qualified electrical engineer or other expert if there are any questions or uncertainties regarding the application of the code requirements. These professionals can provide valuable insights and guidance, helping to ensure that electrical installations are safe and compliant. In addition to the specific code articles discussed, it's also important to be familiar with the general principles of grounding and bonding. Grounding and bonding are essential for providing a safe and effective path for fault current to return to the source, minimizing the risk of electrical shock and fire hazards. Grounding involves connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. Bonding involves connecting various conductive parts of the electrical system together, creating a low impedance path for fault current. By understanding the principles of grounding and bonding, electrical inspectors can better assess the overall safety and reliability of electrical installations. Moreover, it's important to stay up to date with the latest revisions of the National Electrical Code. The NEC is updated every 3 years, and each revision incorporates new technologies, addresses emerging safety concerns, and clarifies existing requirements. By staying current with the latest NEC revisions, electrical inspectors can ensure that they are using the most up-to-date information and best practices when conducting inspections. Continuing education and professional development are also crucial for electrical inspectors. The electrical industry is constantly evolving, and it's important to stay abreast of new technologies, code changes, and best practices. Continuing education courses and professional development opportunities can help electrical inspectors to enhance their knowledge and skills, enabling them to perform their duties more effectively. In summary, inspecting a 3-wire feeder circuit in a detached garage requires a thorough understanding of the National Electrical Code, including Articles 310.2 and 250.118, as well as the general principles of grounding and bonding. By carefully evaluating the installation, verifying compliance with code requirements, and staying up to date with the latest revisions of the NEC, electrical inspectors can help to ensure the safety and reliability of electrical systems in detached garages. Remember to consider any local amendments or interpretations of the NEC that may be in effect, and don't hesitate to consult with a qualified electrical engineer or other expert if there are any questions or uncertainties. By following these guidelines, electrical inspectors can contribute to a safer and more reliable electrical environment for everyone. Now, let's explore some additional considerations related to grounding conductors and feeder circuits. One important aspect is the sizing of grounding conductors. The National Electrical Code provides specific guidelines for determining the appropriate size of grounding conductors based on the size of the feeder conductors. The grounding conductor must be sized to adequately carry the available fault current, ensuring that it can effectively protect the electrical system and prevent hazards. Another consideration is the type of grounding conductor. The NEC recognizes several types of grounding conductors, including copper, aluminum, and copper-clad aluminum. The type of grounding conductor used must be suitable for the application and must be installed in accordance with the code requirements. Additionally, the grounding conductor must be properly identified, typically by its color or markings. The identification helps to ensure that the grounding conductor is easily recognizable and can be properly connected. Furthermore, it's important to ensure that the grounding conductor is continuous and properly connected throughout the electrical system. The grounding conductor must be securely connected to the grounding electrode system, as well as to all metal enclosures and equipment. Any breaks or discontinuities in the grounding conductor can compromise its effectiveness and increase the risk of electrical hazards. In addition to the grounding conductor, it's also important to consider the bonding of metal enclosures and equipment. Bonding involves connecting metal parts of the electrical system together, creating a low impedance path for fault current. Proper bonding helps to ensure that fault current can quickly return to the source, minimizing the risk of electrical shock and fire hazards. The NEC provides specific requirements for bonding metal enclosures and equipment, including the use of bonding jumpers and bonding bushings. These requirements must be followed to ensure that the bonding system is effective and compliant. Moreover, it's important to consider the grounding electrode system. The grounding electrode system provides a connection to the earth, serving as a reference point for voltage and helping to stabilize the electrical system. The NEC specifies the types of grounding electrodes that are permitted, including ground rods, ground plates, and metal water pipes. The grounding electrode system must be properly installed and maintained to ensure that it is effective and compliant. In addition to the technical aspects of grounding and bonding, it's also important to consider the safety aspects. Electrical work can be dangerous, and it's essential to take appropriate precautions to protect oneself and others. Always to energize electrical circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Electrical safety is paramount, and it's never worth taking risks when working with electricity. Let's now discuss some common grounding and bonding mistakes that can occur in electrical installations. One common mistake is improper sizing of grounding conductors. If the grounding conductor is too small, it may not be able to adequately carry the available fault current, increasing the risk of electrical hazards. Another common mistake is the use of improper grounding conductors. Using the wrong type of grounding conductor or installing it incorrectly can compromise its effectiveness. Furthermore, improper bonding of metal enclosures and equipment is a common mistake. If metal parts are not properly bonded, it can increase the risk of electrical shock. Additionally, inadequate grounding electrode systems are a common mistake. If the grounding electrode system is not properly installed or maintained, it may not be able to effectively stabilize the electrical system and provide a safe path for fault current. By being aware of these common mistakes, electrical inspectors can help to identify and correct them, improving the safety and reliability of electrical installations. In conclusion, grounding and bonding are essential aspects of electrical safety. By understanding the code requirements, following best practices, and avoiding common mistakes, electrical inspectors can help to ensure that electrical systems are safe, reliable, and compliant. Remember to stay up to date with the latest revisions of the National Electrical Code, and don't hesitate to consult with a qualified electrical engineer or other expert if there are any questions or uncertainties. By working together, we can create a safer electrical environment for everyone.